Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Here is the fixed vector n, written as a column vector. We want vectors perpendicular to this one. Any vector orthogonal to n must satisfy this linear equation. Our task is to find three non-zero vectors, u, v, and w, that are perpendicular to n and perpendicular to each other. Pause and think about whether you can find simple choices. If you don't know yet, you'll get the satisfying answer in the next steps. We'll start with an easy vector in the subspace. A simple choice is u with entries 1, -1, then 2 zeros. It's clearly in the plane x plus y plus z plus t equals 0. Compute the dot product to verify u is perpendicular to n. Next, we seek v orthogonal to both n and our chosen u. Assume v has the form a, b, 0. This choice makes v automatically orthogonal to u, because the first two entries cancel when dotted with u. Impose orthogonality with n to get 2a plus b equals 0, so b equals -2a. Pick a equals 1 to get a concrete v. It is perpendicular to n and to u. Finally, we find w that is orthogonal to n, u, and v. Let w have unknown entries p, q, r, s. Orthogonality with u gives p minus q equals 0. With v gives p plus q minus 2r equals 0. With n gives p plus q plus r plus s equals 0. Solve these in order. Solving yields p equals q equals r and s equals -3p. Choosing p equals 1 gives this w. Let's check all the orthogonality claims with dot products. U is perpendicular to n. U and v are orthogonal. V is perpendicular to n. V and w are orthogonal. W is perpendicular to n. U and w are orthogonal. All checks pass. A quick recap of what we constructed. One valid choice is u equals 1, -1, 0, 0. V equals 1, 1, -2, 0. And w equals 1, 1, 1, -3. Each is non-zero, orthogonal to n, and pairwise orthogonal. They span the three-dimensional subspace perpendicular to n. Nice work following along. Watch the next video to learn more tricks for building orthogonal sets and orthonormal bases. It'll be fun and a little bit silly.